Good afternoon to everybody. I'm Paolo Mollo from CSP, that is a research center placed in Turin and focused on activity related to innovation in ICT sector. In this talk, we will see how the Internet of Things could be used, could help to make smarter environments in our everyday experience. CSP in particular is an applied research center, so that means that all the projects and all the prototypes realized by CSP must have an on-field direct impact, helping to the community or some territories to improve their life conditions. The last but not least step of the CSP activity is the technology transfer from the research prototypes to the SME. In the Internet of Things, CSP works in all the plans here showed, from the sensor nodes, so from the sensing layer, until the services layer in different application domains like agriculture, environment, smart city, and so on. We will see in details. What are the main technological challenges that have been already during the day, in the talks during the day, well analyzed in depth? Sure, the standard development for communication and interoperability, the availability of the spectrum and the users' policies of it. And also, we heard a lot about it, the energy harvesting by new renewable energy sources. What are the other issues? Sometimes an industrial opposition to interoperability, most important privacy constraints, and the data are becoming more and more sensible, and so on, the IT, information technology security issues. The key enabling technologies are also been well presented during the day, but the most important are sure the wireless sensor networks and the protocols, and the low energy, the microsystem with low energy consumptions, even power supplied with energy harvesting technologies, the sensor technologies, and also the big data analysis. When you have a large amount of data, you must elaborate them in the best way. So, what is the activity of CSP with the Internet of Things? The heart of the overall system is the Internet of Things platform. That is a platform where that hosts a distributed database, not only SQL database, where data acquired from heterogeneous sources are sent, so from sensor or webcam. Data are elaborated and also used through web services in different ways. This is an example of the Internet of Things platform that this is, for example, a technological front end through which the data that are presented in a georeferred way could be elaborated and also showed like the webcam. Another example that is a public site, www.iotnet.it, show another example of a front end that is built on the same backend of the Internet of Things platform. Here the data are divided by teams, by sensor typologies, and another important thing is that the data are validated. To send the data to the IoT platform from different points all around the territory is very important, the geographical access network. In the last 10 years, CSP has developed in the Piedmont and now also Liguria regions an high-performance wireless access network. You can see the blue point are the point characterized by the optical fiber. From the optical fiber point, there is a backbone realized entirely in HyperLAN 5 GHz technology. This is an approach that allows the quick activation or the quick recovery of access node in case of fault. This is called tactical networking. From the broadband, now we are moving also to another technology, the digital mobile radio, because for the Internet of Things, the important thing is to spread the coverage, but the data rates are low. So we have put 3 base stations of digital mobile radio technology that, as you can see from the pictures, cover the whole region of the Piedmont. So now we can start to see the projects that use the Internet of Things approach realized by CSP in collaboration with the local entities. The first example in which IoT can improve the everyday experience is the Nimbus project realized with the Italian Meteorological Society of Luca Mercalli. This project aims to monitor climatic parameter at a glacier of 2,850 meters of altitude. So before this realization, technicians went to the glacier every 6 months to collect data from the station. Now, every 2 hours, the data are available in the platform. And also the webcam show for 20 minutes the pictures of the glacier and the conditions. Another key enabling technologies, very, very important, are the wireless sensor networks. So the goal CSP has worked on wireless sensor network was to increase the duration through energy optimization from 3 points of view above all: hardware point of view, ultra-low power communication protocol, and also energy awareness algorithm in the node firmware. We use in the environment application frequency in the industrial, scientific, and medical band, so from 2.4 gigahertz and also in Europe 868 megahertz. 868 megahertz from tests we have done is better in environment condition with important presence of tree, of forestry, and so on. One of our test bed to test new solution of ultra-low power protocol is a wireless sensor network deployed in the Botanical Garden of Turin. This is used also by the professor of biology university to study the phenologic phases of the trees. As you can see from the pictures, this node could be power supplied by battery, but also with energy harvesting system with micro solar panels. One of the topic we work since 2009 is the wine growing sector, because IoT can improve the work of agronomes that go every day to vineyards. In this case, the first project was the SIGEVI Project. That is a project realized in the Cuneo province with a producer of Nebbiolo wine for Barolo, that is Cappellano. So the SIGEVI project wanted to use the IoT concept for monitoring the vineyards, and in particular the agri-meteorological parameters, in order to avoid phytopathologies outbreak. So there are some pathologies like Peronospora oidio that when you see them, there is too late, because the pathology has already ruined your winery, your vineyards. So in this project, the main goal was the reduction of phytopharmaceutical use, switching from a calendar-based approach to a biological control scheme. So if you use phytopharmaceutical with a calendar approach, okay, you treat the vineyards every 2 weeks, 1 month, from a calendar approach. But measuring the agri-meteorological parameter, and also with wireless sensor network, the microclimatic zone, you can use less phytopharmaceutical with a best performance in terms of less pollution to the earth and also of economical behavior. In this case, we used, for example, the 2.4 gigahertz technology for the wireless sensor network in the vineyards, and the Hyperland technology from the gateway to the Internet of Things platform. The success of the SIGEVI project has done the boost to start with another project, SIGEVI, that is a project that ended in March 2015, so 2 months ago, that aims to create a management system of wine growing district for programming treatments and also crop phases. The point of strength of this project was the collaboration between the 3 basic components: the agronomist, the ICT researchers, and the agriculture researchers and the ICT technologists. So the DSS is a platform in which hosts historical data, on-field sensing data, and also an Android app with which the agronomist can send to the platform the different phases of the nature during the summer period of the vineyards. In this case, this is the monitoring system. We measure the temperature and humidity in the air, the photosynthetically radiation, the soil moisture and temperature at 20 centimeter and also 40 centimeter, and also some innovative vegetation index, like NDVI. In this case, the wireless sensor network that we have developed in the Botanical Garden of Turin was realized in a vineyard in Asti Agliano Terme. So we used the radio frequency of 868 MHz with the star topology, with an ultra-low power protocol, and the wireless sensor network that also uses self-healing and self-recovery procedures. That means that if the access point go down, the sensor don't waste energy until the access point is up again. In this case, for the long-range technology wireless coverage, we use the digital mobile radio to reach the IoT platform. This is an example of the app developed for Android. So now the agronomists that work in this project use the tablet instead of their book. And then also with the tablet they can see the results and the comparison of this year with the previous year, because it's very important in the wine growing sector to have the idea of how will be the crop compared to the previous season. And this is possible with this elaboration tool, with this decision support system. Another scenario in which IoT can be used in depth is the smart city scenario. The European project Everywhere was developed from 2010 to 2012, and the main goal was to increase the citizen awareness about the air quality, the outdoor air quality. How? Realizing a mobile sensor node that interact from one side with the cellular, with the smartphone, through the Bluetooth technology, and on the other side to the IoT platform. So the user was had a backpack equipped with the sensor box, and the sensor box senses different gases like CO, nitrogen dioxide, volatile organic compounds, and ozone, plus temperature and humidity for calibration. The goal was an indirect evaluation of black carbon, that is a well-known parameter to evaluate the traffic pollution. In this case, we will see on the left side the map that the user can see on his smartphone, because for the privacy he can see only his path. On the right side we can see the restitution of an aggregated map. Another way we used to monitor the air quality has been the vehicles, the bus vehicles. For example, the electrical bus. This was a project with the GTT, that is the transport public company of the municipality of Turin, that make a tour and use a vehicle to infrastructure communication protocol to exchange data with the network every time it passes near an infrastructure node. Another way is to place some fixed monitoring station. In this case, in this project realized with ARPA Piemonte and also CSA Piemonte, we placed some fixed station that monitor nitrogen dioxide, ozone, and also particulate matter, and that have a Wi-Fi connection towards the Internet of Things platform. So the starting point was that there are a lot of, there are few precise monitoring stations that have very high costs. So the aim of this project is to estimate in a reliable way the error between low-cost sensors and certified instruments, and where possible elaborate calibration coefficients in order to achieve the goal to put more and more reliable low-cost sensors that give reliable data, improving the extensiveness of sensing points. More and more important is to make a comparison between the outdoor air quality and the traffic. For example, we can use this algorithm that we developed that don't use invasive solution like sensor in the street, but use images taken by the webcam deployed on field. Finally, another topic that is becoming more and more important is the indoor air quality monitoring, because as we know, furniture and appliances release a lot of substances, but also there are new hidden hazards, as said by the European community, that are the paint that release, for example, formaldehyde. So in this case, still with CSA Piemonte, we developed a solution called Aladdin's that measures the levels of volatile organic compound and formaldehyde, and gives to the user, to people that stay in the room, an assessment of the environmental air quality through three easy to read colored LEDs. The green LED means that the indoor air is clean. The yellow LED is the first threshold of alarm. The red LED means that the indoor air quality is very bad. Also, in this case, the data collected by sensor are sent to the platform using the Wi-Fi connection at regular intervals. Conclusions. In these experiences and this project, we have seen that IoT applications have a huge potentiality on the market, but they don't need for high data rates, but more and more for wide geographical coverage. And the importance of always take care about energy consumption, even in device, even in protocols. Thank you.